I'm going to show you how to factor the sum or difference of perfect cubes. So there's two formulas based on whether it's either the sum, which we use this formula, or whether it's the difference, which we use this other formula. And you need to make sure that what you are trying to factor is actually two perfect cubes. So x to the third is x times x times x. It's a perfect cube. 27 is 3 times 3 times 3. Now let's say it was a number that might not be so obvious. You can just go to your calculator. I'm going to use Desmos, and I'm going to click on the cube root button, and I'm going to type in 27, and it tells me that the cube root is 3. And so in this situation, my formula that I'm going to use is going to be the difference formula, so I'm going to be using this formula, and my a value is just x, and my b value is 3. And I'm going to follow this formula. So the formula says take a, subtract b. All right, so I've got a subtract b. So it's just the cube root of those things. The cube root of x cubed is x. The cube root of 27 is 3. And then I'm going to take that a value and I'm going to square it. So that would be x squared. Then I'm going to multiply the a and the b value together. So that would be x times 3, which is 3x. And then I'm going to square the b value. So that would be 9, because that's 3 squared. So again, what I did here is I take the a and b. I'm getting them by doing the cube root. So like the cube root of x cubed was x. And so I'm going to take that value and I'm going to write it here. And then I square it and write it here. The next part is to figure out what b was. B was 3, because that's the cube root of 27. So I put that value here, and then I square that value here, 3 squared. The middle comes from just multiplying those two things together. 3 times x is 3x. So that's where they come from. Now, in order to check this, you could redistribute. You can also put it in your calculator to check to make sure that they're the same thing. And so if I go to either a graphing calculator, y equals, or my Desmos calculator, I'm going to do x to the third minus 27, and then I'm going to type in what I got, x minus 3, and then I had x squared plus 3x plus 9. And if my two different graphs overlap, which they do, then I factored correctly, because factored form is just a different form of standard form. All right, my next example is a sum problem, so I'm using the first formula. All right, so I'm just going to go ahead and write that first formula down again so that we have it. It goes like this, a plus b. So when it's sum, you start off with sum, and then it goes a squared minus ab plus b squared. And so for this one, the only minus sign is in the middle. And so I'm going to figure out my a and my b. So my a value is going to be x again, because it's just the cube root of x cubed. My b value is going to be 4, because 4 times 4 times 4 is 64. So the cube root of 64 is 4. And then I just plug in. So x plus 4, you take the cube roots, add them together. Then you're going to square x minus plus, I'm going to go ahead and square 4. So I square x at the beginning, square 4 at the end, so 4 squared is 16. And in the middle, you just multiply these two things together. So x times 4 is 4x. And voila, there's my formula, all plugged in. All right, number 3 is a little bit harder. Number 3 is hiding behind a GCF. So always when you factor, you look for a GCF first. And so my GCF is 2. They're both divisible by 2. So now I have 8x to the third power minus 1. And I need to know, well, is 8 a perfect square? Yep, 2 times 2 times 2 is 8. X cubed is, I said perfect square. I meant perfect cube. 8 is a perfect cube because 2 times 2 times 2 is 8. And x is a perfect cube because x times x times x is x cubed. And then 1 is a perfect cube because 1 times 1 times 1 is 1. So my a value is going to be 2x, and my b value is going to be 1. And again, I get that because the cube root of 8x to the third power is 2x. That's where that comes from. All right, so now I'm going to plug into the formula. So the formula says to do, for differences, a minus b, a squared plus ab plus b squared. And so I have 2x minus 1. It's just the cube roots of those things. Oops, the 2 goes on the outside. The GCF stays out here. And then I have my a minus b, which is 2x minus 1. And then I'm going to square 2x. If I take 2x and I square it, that gives me 4x squared. Plus a times b. A is 2x, b is 1, so that's 2x. Plus b squared is 1 squared, which is 1. And then don't forget that you can check this by plugging in the original problem and your answer into the calculator and making sure you see one graph.